Well, hi everybody. We are going to be dissecting a deer heart in a few minutes. I had indicated to you that it was super important that you took some time and studied the heart anatomy before you actually viewed this video of the dissection. So it's really, really critical that you get into the textbook and begin to look at the first section of chapter 15 on the cardiovascular system. Because when you do that, it's going to talk a lot about general characteristics of the heart and get into some of the differences between the pulmonary and systemic circuits, which you probably remember learning about a little bit in the respiratory system. But you definitely, again, want to make sure that you've taken some time and you've looked over the first couple sections of chapter 15 before we get into the dissection. In the lab book, exercise 38 is entitled Heart Structure. And had we been meeting, we would have gotten together and done probably some sheep hearts or some pig hearts or some deer hearts. And so these are, again, very, very good diagrams for you to look at. You should be able to label this frontal section of the heart with the various chambers and valves and so forth. And there's also some models that we have in lab to look at. And since we won't be able to do this because of COVID, I'll be posting some videos on the Blackboard course shell that talk about different heart models. And again, they point out some of the different anatomical features. So please, again, make sure you have looked over the PowerPoint presentation in chapter 15 before you actually watch this dissection. In a few minutes, we're going to pull the deer heart out and show you some structures. But one thing that I do want to talk a little bit about, so you're aware of what you're looking at, is the fibrous pericardium, which is this sac that surrounds not only the deer heart, but your heart as well. And you're going to see some fat on the surface of this fibrous pericardium. You'll also see fat on the very surface of the heart as well. So this fibrous pericardium is a very tough sac. And I think this little insert here of figure 15.4 does a nice job sort of depicting the various components here of this fibrous sac. If I can get this to focus. Which it's not wanting to do. Anyway, reference this section here in your book. I'm sorry that it's not focusing as well as I'd like it to. So you're going to see this somewhat thick, semi-transparent fibrous pericardium on the surface of the heart. And I want you to note that on the very inner surface of the fibrous pericardium is something called the parietal pericardium. So that's this structure right here. So this is on the inside of the fibrous pericardium, the sac. It's a very thin membrane, the parietal. And then that parietal pericardium will fold back upon itself to form the visceral pericardium. And we said that the visceral membranes are those that cover the surface of the organ. Now, in this case, pericardium refers to heart. So the visceral pericardium is on the surface of the heart itself. It's a very, very thin membrane. This is denoting the cardiac muscle. And between the parietal and the visceral pericardium is this pericardial sac or cavity, not sac, but cavity. And this is containing pericardial fluid, which keeps friction from developing as the heart is contracting inside this sac. So it's a lubricant, pericardial fluid inside the cavity. Okay, I'm going to stop here and we're going to get the heart dissection ready to go. So hang on. Okay, so here's our deer heart. And just to point out a couple of features here, one thing that we just mentioned a few moments ago is the fibrous pericardium, which is on the surface here of the heart. That's this rather thick membrane that you can see right here. Note again the amount of adipose tissue or fat here on the very surface of the fibrous pericardium. That is pretty typical, not only of deer, but of people too. So I'm going to kind of open this up a little bit and cut the fibrous pericardium so we can see the actual heart underneath. So I'm going to fold this back. Now remember, we said a moment ago that on the inner surface here of the fibrous pericardium was the parietal pericardium, which folds back on itself to form the visceral pericardium here on the surface of the heart. So if I take a small little incision here of the myocardium, I'll find a very, very thin membrane. I'm not sure I'm going to be able to find it here. Pull it out. But if I can, this very, very thin membrane is the visceral pericardium. You just see it basically through the probe here. Very, very thin membrane. Okay. So I'm going to continue to remove the fibrous sac, fibrous pericardium of the heart, so that we can see some other features. I'm going to just trim this here. All right. So here we've got the apex of the heart toward the bottom, and the aorta and the pulmonary veins and arteries would be here toward the top of the heart. I want to point out a couple structures that you've read about. This is one of the atria, sometimes called the auricle, because it looks like an ear. Auricle means ear. So we'll determine whether this is the right or left atrium, the superior port of it, in just a moment. If we turn the heart on the side, here would be the other auricle. This would be, again, the superior portion of the other atrium. Note that in addition to the fat that we saw here on the fibrous pericardium earlier, we've got a lot of adipose tissue here on the surface of the heart. And that's pretty normal. What we're going to do next is we're going to make an incision through one of the auricles. I'm going to choose this one. We're going to head on down toward the apex of the heart to try to determine whether this is going to be the right or the left atrium that we're going to cut into. And I'll tell you how we're going to determine that in just a minute. So let me find the center of this auricle, and I'm going to make a straight line incision down through it. And as I suspected, this is the right auricle, the right atrium. As we look inside, we can find the tricuspid valve. Remember, there are two AV valves, or atrioventricular valves, the tricuspid and the bicuspid valves. The tricuspid valve lies between the right atrium and the right ventricle. And the reason that I know that this is the right side of the heart is because here we have the wall of the right ventricle, and it's thin, because the blood coming from this chamber is being taken a short distance to the lungs. Okay, so we're looking now into the right atrium. See the myocardium of the ventricular wall. And here is a papillary muscle, right here. The reason I know that is because it's connected to these cord-like structures called chordae tendineae. And these chordae tendineae anchor the valve, the tricuspid valve, to this particular papillary muscle. And there'll be other papillary muscles as well, but this is one of the larger ones. And so as we trace these chordae tendineae upward, superiorly, we can encounter the tricuspid valve. And so we can see just underneath the probe, this very thin material right here, very, very thin. This is one of the cusps, one of the three cusps of the tricuspid valve. We have another cusp up here, and then there'd be another cusp attached to another papillary muscle here on the other side. In fact, where my thumb is pointing, here's another large papillary muscle. And again, I know that because it's attached to chordae tendineae, and there's a nice view of the chordae tendineae here. I'm going to put this white part of the knife underneath, and then you can see those very nicely. See those white cord-like structures? And again, these are anchoring the papillary muscle to this part of the valve. I'm going to do the same thing on the other side, so again, you can really see these white cord-like structures, maybe not, against a white background. Get in there now. Yeah, you can see a couple of them there. They're very strong cords. And what they do is when the right ventricle contracts, this papillary muscle also contracts, and it prevents prolapsing of the AV valve back into the atrium. So that's what they do. They pull on the valve when the ventricle contracts, so the blood doesn't regurgitate back into the atrium. Because remember, the blood is moving from the right atrium into the right ventricle. And then from the right ventricle, it's being taken out the pulmonary arteries to the lungs. Okay, so this is again, right atrium, tricuspid valve, chordae tendineae attached to several of the papillary muscles. This interesting structure right here is called the moderator band. And it sort of lies between the right ventricular wall and the interventricular septum, which is right here. Interventricular means between the ventricles. Let's go to the other side of the heart, to the left side. So this is going to be the left auricle, which is the superior part of the left ventricle. And then pretty much everything between my index finger and thumbs is going to be ventricle, in this case, left ventricle. And I'm going to be looking for a thick wall here. Remember, on the right side, I had a thin-walled right ventricle. Now, on the left side, I'm going to have a thick-walled left ventricle. So I'm going to make another straight line incision through the left atrium, to the auricle of the left atrium, all the way down to the apex. And when I do this, I'm going to have to cut a lot deeper than I did on the right side, because again, the left ventricle wall is much thicker. So there we go, we've cut through that. We've got a large blood clot here. So I'm going to remove that. I hope it'll be kind of gross, but we'll just have to deal with it. So we'll remove this clot a little bit. Let's see down in there a little bit better. So again, here we've got the left atrium. Here we have the thick-walled left ventricle, the myocardium of the left ventricle. And of course, what do we have right here? These white cord-like structures that are anchoring a papillary muscle. So these are the chordae tendineae, they're called. Chordae tendineae. Very strong fibrous cords. These are going to be attached now to another AV valve, atrioventricular valve. This is the bicuspid. Remember, on the right side, between the right atrium and right ventricle, we have the tricuspid. On the left side, we have the bicuspid. There can be two cusps. And we can see one of them right here very nicely underneath my handle of my knife. See it? See the knife just through that rather thin but yet strong cusp. And then as I look from this other side, here's another large papillary muscle right here. Here are some more chordae tendineae. Shown very nicely against the white handle of the knife. And again, if we trace that superiorly, that's going to take us up into the other cusp of the AV valve. 2 cusps on the left, 3 cusps on the right. Okay. So let's go to the right side again, and let's now look for one of the 2 semilunar valves. From the right ventricle, we said blood is taken to the lungs via the pulmonary arteries. And so this structure right here, this white structure, is called the pulmonary trunk. Pulmonary trunk. So this is leading to the lungs. It will split into the right and left pulmonary artery, the right pulmonary artery going to the right lung, the left pulmonary artery going to the left lung. So at the very base of this white structure, you see some of the connective tissue here in white. At the base of this, where it meets the myocardium of the right ventricle, will be the pulmonary semilunar valve. So I'm going to take my knife. I'm going to make a straight line incision now through the wall of the right ventricle up into the pulmonary trunk. And we'll look for that pulmonary semilunar valve. And we've gone through pulmonary trunk. And here's the semilunar valve. Here's one of the cusps I'm going to have to cut through here. So here is one cusp. Right here, very thin. I have another cusp on this side, and I have a more intact third cusp right here. It's very, very thin. Get my knife underneath here so you can see it. Can you pull it out? There you go. Got a better view of it. One of the cusps. 1, 2, and part of the third. Notice there's no Purkinje fibers, no papillary muscles associated with the semilunar valves. Each semilunar valve has 3 cusps. This again is taking blood into the pulmonary trunk, which will split into the right and left pulmonary arteries as the blood is taken to the lungs to be oxygenated. Once the blood comes back from the lungs, it's going to travel through the 4 pulmonary veins. 2 of them will travel from each lung and eventually make their way into the left atrium. So let's go back. Here we are on the left side. I know that because of the thick walled myocardium. I'm not going to look for those 4 pulmonary veins because of the way this deer heart was cut out of the animal. It was cut, I guess, too high to really catch those veins. So we're not going to bother to look for them. But remember, the blood's coming into this chamber, the left atrium, passing through the bicuspid valve into the left ventricle, which is this. To find the other semilunar valve, which is the aortic semilunar valve, I'm going to take a pencil and I'm going to insert it up underneath the bicuspid valve, and I'm hoping that it will come out the aorta. Okay, so here's the end of the pencil coming out. This is the aorta right here. Got my index finger inside the aorta. You remember from one of the earlier chapters that this is made up of elastic connective tissue, rich in both collagenous fibers and elastic fibers. The collagenous fibers are there to provide strength and rigidity to the wall of the blood vessel, and the elastic fibers are there to stretch, because remember, blood coming from the left ventricle is being pumped under a great deal of pressure. Remember, the wall here is thick. It's thick because it needs a great deal of pressure to pump the blood through the systemic circuit. Remember, on the right side, it was going through a rather short distance to the lungs, so it didn't have to be pumped under as greater pressure. So what I'm going to do now is I'm going to take the knife and I'm going to cut up through the bicuspid valve to the aorta, and at the base of that aorta, I'm going to find my other semilunar valve. So I'm going to leave the pencil there. I'm going to stick the knife right up in there. I'm going to follow that cut and open that up. And there we can see our aortic semilunar valve. Here's one of the cusps right here. Here's another cusp right here. And here's another cusp, showing pretty nice against the white of the wall of the aorta right there. These are very thin valves, very thin. Most people are quite surprised at how thin they are. Okay. So again, aortic semilunar valve, 1, 2, and 3. We don't see the arch of the aorta here because, again, it's been cut in such a way to prevent us from seeing that arch. But there will be branches that branch off of the heart. Again, you might remember from chapter 15 that we've got several branches coming off of the arch of the aorta. And that pretty much is the dissection.